So I want to welcome you to this segment of my physics videos as we look at concept under time and length. So we are going to focus on time so that we can give you ideas on what you need to do when it comes to measurement of time. There are so many definitions of time, but in simple terms I can simply say time is the interval. Time is the interval between events. Yeah, so the interval between events that are taking place, that is what I can call as being time. If you remember from our previous discussion, we did say that the SI unit for time is simply the seconds represented by small letter s. But of course, there are other units that we can use for time, depending whether the time is too big or too small. But in most cases, you may be dealing with units that are actually smaller, such as what we called as being ms, that is representing millisecond. And if you remember, millisecond, 1 millisecond is equal to 1 millisecond is equal to 10 raised to the power negative 3 seconds. You can also have what we are calling as being microseconds. So 1 microsecond, remember micro means 10 to the power negative 6 second. You can also have nanoseconds. So 1 nanosecond is equal to 10 raised to the power negative 9 seconds. So you can use also these smaller units in order for you to express your time, as you are going to see in various discussions. But I want you to remember that time can be measured in a lot of things. It can be measured in in seconds, in hours, in minutes, in weeks, in years, and so on and so forth. So there are a lot of units. But what we need to know is that what are some instruments, what are some modern instruments that can be used for measuring time. So there are a lot of instruments that we can use, but I'm just going to talk about the modern instruments that we can use for measuring time. Maybe one, I can talk about a watch. Yeah, so usually a watch could use vibrations of a quartz crystal under electric current for precise timing. You can also have what we call as being a digital clock. Yeah, so for a digital clock, it actually displays time using digits, often powered by batteries, or it could be electricity. You can also talk about a stopwatch. For a stopwatch, it actually measures short time intervals with high precision, and oftentimes we can use it. We use it in the lab, and it can also be used in sports. The other one that we can talk about is simply a timer. So we can use a timer. So for a timer, it counts down from a set time, and usually these are the ones that are commonly found maybe when people are cooking or when we are carrying out experiments. We can also use what we are calling as being a timer. So there are a lot of instruments that you can use. If it's way back, people could also use the shadow in order to determine time. Sometimes we can use another instrument that we call as being a simple, we can also use a simple pendulum. And in my discussion for time, we are going to focus on what we are calling as being a simple pendulum. Therefore, we can ask and say, what exactly is a simple pendulum? Well, we can say that a simple pendulum, let me say that a simple pendulum, so a simple pendulum is a device, made up of a heavy mass, and that heavy mass is what we call as being a bulb with a string. So let me say with a string, but this string is simply a light inextensible. It is actually a light inextensible string that we're talking about, meaning it doesn't stretch. It is very light, and also it is inextensible. You cannot extend it. So a device made up of a heavy mass, and that heavy mass is what we are going to be referring to as being a bulb with a string, a light inextensible string. That is what we simply call as being a simple pendulum. Let me just show you how a simple pendulum looks like. So if I was to draw one here, we can illustrate it this way. We can illustrate it this way. So all right, so this is what we are calling as being a simple pendulum. So it is made up of what we call as being a heavy mass, which we are calling as being a bulb. And also you have got this point here is what we call as being the point of support. So that is what we simply call as being the point of support, if you want. Sometimes we can call it as being the pivot, or let me just call it as being the support point. Now there are a few terminologies that you need to remember that are associated with a simple pendulum, and I want to run you through them so that you are able to actually understand what are these terminologies that are involved. For example, if this is the bulb, the center of the bulb, from the center of the bulb, if you are to measure from the center of the bulb to the support point or the fixed point, the support point sometimes may also be called as being the fixed point, which I'm also calling as being the pivot. So if you are to measure the distance from the center of the bulb to the fixed point there, this distance that we have there, I'll call it L, that is what we call as being the length of a pendulum. So this is what we call as being the length of a pendulum, and I'm calling it as being L. So that is what you need to remember. Of course, different books will tell you the length of a pendulum may be different depending on the reference point, the starting point, where they're starting from to the to the fixed point or the support point that you do have. So let's look at a few terminologies that you're going to to come across that you need to know. So the terminologies that are associated with a simple pendulum. Number one, we can start by defining what we are calling as being the length of a pendulum. So the length of a pendulum, which I'm calling as being L. So what is the length of a pendulum? Well, like I said, the length of a pendulum is simply the distance between the center of the bulb and the fixed point. So the distance between the center of the bulb and the fixed point, that is what we call as being the length of a pendulum. So we can say is the distance, so we can say is the distance between the pivot, which I'm calling the fixed point or the support point, to the center of the bulb. So that is what we call as being the length of a pendulum. Right. The other terminology that you need to come across, that you need to know, is what we call as being the period of a pendulum. So period of a pendulum. The period of a pendulum is represented by a capital letter T. Now when it comes to the period of a pendulum, we simply say it is simply the time for one complete oscillation. In other words, the time taken to make one complete oscillation. So period of a pendulum, is the time taken for one complete oscillation. So the time taken for one complete oscillation, that is what we simply call as being the period of a pendulum. So you need to remember just the time taken to make just one complete oscillation. That is what we call as being the period of a pendulum. In fact, the period of a pendulum is given by the formula. So we can write up a formula there. The period of a pendulum is given by the formula. So we can simply say period represented by capital letter T is equal to the number of, so we can, that is going to be given by the time taken. So we are talking about the time taken divided by the number of oscillation, or the number of swings that are made. So time is represented by small letter t and the number of oscillation by small letter n. I can therefore say that period is equal to time over the number of oscillations there. So period is the time taken, and remember the SI unit for time is in seconds divided by the number of oscillations that we do have. Then the SI unit in which period is measured is simply the seconds. So you need to remember we still use the seconds too as the SI unit for the period of a pendulum. All right. So in later discussions, as you discuss, as you look at some other experiments, you are going to find that the period of a pendulum, when you look at more advanced concept under that, the period of a pendulum later on, I'll show you an experiment that you can do, can also be given by 2 pi, then the square root of the length divided by gravity. Of course, you can just take note of this formula. Later on, we are going to be applying it. I'll show you there are various experiments. We can use this formula to help us determine the acceleration due to gravity here on Earth. Let's look at another terminology, the frequency. So we can simply say frequency of a pendulum. So the frequency of a pendulum is represented by small letter f. But what exactly is the frequency of a pendulum? Well, the frequency of a pendulum is indicating or indicates the number of oscillations per second. So that one we can say is the number of oscillations, per second. When I say the number of oscillations, in other words, how many complete oscillations are made in just 1 second. Yeah, so how many oscillations are made in 1 second? For example, if you make 10 oscillations, yes, so if you make 10 oscillations, sometimes called swings, if you make 10 swings in just 1 second, then it simply means your frequency is equal to 10 Hz. If you make 50 oscillations, or swings in just 1 second, as long as these are made in 1 second, it simply means your frequency, you just take the 50 and the Hz. So as long as they are being made in 1 second, that is what we call as being the frequency. So you can apply the formula that we use. So the formula that you can apply to calculate the frequency, it simply says frequency is equal to the number of oscillations. So the number of oscillations represented by small letter n divided by the time that has been taken. So that is what we know. We can use their small letter t. In other words, it's the opposite of the formula for period of a pendulum. So frequency therefore is equal to the number of oscillations divided by time. The SI unit that you need to remember is Hz. So we use Hz, which is represented by capital letter H and small letter z. So that is what we mean as being Hz. But you need to remember that 1 Hz, is equal to 1 per second. So 1 Hz is equal to 1 per second. That is what we mean. So Hz and per second are just the same. So that is what you need to remember. Now let me just slightly try to misbehave a little so that I can show you before I continue with some few things. We realize that the period of a pendulum is equal to time over number of oscillations, and frequency is equal to the number of oscillations divided by time. That's what we have said. If you can see, it's just the opposite. It simply means that if I want to calculate the period there, I can also use the formula related to the frequency by simply saying, 1 over the frequency. So you can also apply this one to calculate what we are calling as being the periods. If you know the frequency, you can say period is equal to 1 divided by the frequency. Similarly, if we exchange that, it simply means that the frequency can also be 1 divided by the period, meaning that if you know the period, it is possible for you to calculate the frequency. So that is the relationship that is existing between period and also the frequency of a pendulum. All right. So before we move on and I show you, I want you to understand some few concepts here. I've been talking about oscillation. What exactly is, is the definition for an oscillation? So let's put up some few golden tips there. We can simply say when it comes to oscillation, sometimes called cycle, the number of cycle, that's what they can be using. Oscillation, sometimes they can use cycle, the number of cycles. So for one, an oscillation is the complete, we can simply say, is the complete swing, of a motion. So the complete swing of a motion, you can think of it, you start from a point here I'm calling as being point A, then I go around and come back to the same starting point. I've completed, a motion. So that's what we call an oscillation, a complete swing of a motion. And that is what we call as being oscillation. Sometimes they can say the number of cycles. Do not worry, oscillation cycles, those words are going to be used interchangeably. There's another terminology that I want to bring to the fore that you need to remember. Imagine I do have that as my simple pendulum. Remember what we said? You can have your bulb at this point. When the bulb is in this position, this is what we call as being the rest position. So when it is in the vertical position, we call it as being the rest position. But imagine now you move it, you pull it to one side. So if you pull it to one side, you find that an angle is going to be created there. So an angle is going to be created. Let me call it as being A. The new position where you pull it, whether it reaches the maximum, this is what we can call as being the displaced. So this is the displaced position. So this is what we call as being the displaced position. So now this angle here created between the rest position and the displaced position, this is what we call as being the angular. So you can call this one as being, the angular amplitude. So you can call it as being the angular amplitude. Sometimes in some books, they'll just call it as being the amplitude. That is what you need to remember. So they'll just call it as being, the amplitude. Now, what exactly is the angular amplitude there? Well, when it comes to the angular amplitude or the amplitude, so the angular amplitude, which I'm representing by capital letter A, is simply the angle between the rest position and the displaced position. Or if you want, we can simply say it is the maximum angular displacement. So the maximum angular displacement from the vertical, that is what we can, so the maximum angular displacement from the vertical, that is what we can call as being, the angular amplitude, sometimes called as being the amplitude. Or you can also define it as the angle between the rest position, and the displaced position. So that is what we call as being that. Well, watch out as I show you factors that are affecting period of a pendulum, and we look at some other calculations in my next video. Thank you so much for watching.